Thank you all for joining us. Today, we're going to be talking about healthcare facilities and critical environment air distribution products from MetalAire by Greenheck. Our standard housekeeping rules. We have everyone muted and cameras off, so please ask all of your questions in the chat and do our best to moderate those. This is being recorded and we'll get it uploaded to our Dorse YouTube page so you can reference back to it in the future. All the presentation you see, we're happy to do this for your engineering or contracting team in the future if you'd like one dedicated for your firm. As always, we have Scott Boucher, our senior most sales engineer out of our Seattle office, our VP of engineering, and we have Blake Bonham, our sales engineer of our Spokane office. So we have a dedicated engineering support team. Along for some of those of you who work with contractors, you have your Dorsey account managers as well. So with that, we're going to let Matthew McLaurin take over. I have worked with Matthew for probably 13 or 14 years over the course of our careers. And as you will hear, he is an expert in critical environment and healthcare applications for air distribution. I have seen many of his presentations and I always learn something new. So with that, Matthew, take over, give yourself a nice little background introduction here, and we'll take over and moderate the chat.
Absolutely. Yeah, so thanks everybody. A little bit about me, the engineering manager for our GRD group. Got 17 years of experience with air distribution, specifically GRD, ATU, chill beam displacement. I've got 13 years specifically that's focused on healthcare and clean room product offering. I've had my healthcare facility design professional certification the past 12 years and recently served on the committee working to review the certification test and program and review any of the content to update to match the current versions of the standards that those are being applied to. Pretty active in TC 5.3 and 9.6 air distribution healthcare facilities, both the handbook and research subcommittees. And then currently I'm serving on standard 170 on the interpretation subcommittee. So to get started today, we'll cover laminar flow diffusers, our operating room systems, move on to our radial pattern option diffusers, and then wrap up with fan filter and then any questions you might have. So the first group we'll talk about is a groupie non-aspirating diffuser. This is really more widely known as a laminar flow diffuser. You look here, we've got our HLC MPA, that's our modular plenum array system. Here you'll see the diffuser arrangement laid out all together. You see the airflow coming down into the room, nice and even and uniform. We're trying to minimize any mixing. And so standard 170, they have the requirement that calls out a groupie non-aspirating diffuser. So unidirectional flow down from the diffuser, minimum entrainment, and really where we're driving with that is that no aspiration of room airflow into the flow. So if we look at a quick animation of what aspiration is, you've got this room air motion that's being pulled along with that supply airflow. And then as it starts to move into the room, you see it really starting to mix into that flow, and it's one combined flow. That's what we're meaning when we're talking about aspiration. And that's your traditional type diffuser. What we're really trying to achieve is none of that. So no aspiration. So you're going to have that airflow coming down into the room very, very slowly. What you will still have is entrainment, and that's just kind of part of the physics of the device. You have that fluid coming into the room. It's not mixing with that room air, but because of that velocity, there's friction with that fluid that's already into the room, and so it pulled along the flow line. So there is going to be some minimal amount of entrainment along with these diffusers. And what we're going to try to do with those is minimize the surface area of that flow coming out of the diffuser, so that minimizes that border around the diffuser where that entrainment occurs. So the more uniform velocity we have across the face, the smaller the surface area of that flow, the lower the entrainment levels. So one space that we really talk about where these get used are protective environment rooms. So here from the air distribution standpoint, you need a Group B non-aspirating diffuser with a terminal HEPA filter and placed over the patient. So this is one of the kind of secondary places where we see the requirement for the Group B non-aspirating diffusers. And this one specifically has a requirement for the terminal filter or terminal HEPA filter, so in the diffuser itself. Part of where this requirements come from is from the filter manufacturers that help participate in Standard 170 and develop those codes. What they've presented to 170 downstream of some of what would have previously been referred to as filter bank 2 in Standard 170, so downstream of the coil, but still in the air handler for the most part. If you had filtration there, downstream of those filters, you would still have additional growth that could get into these applications that may cause healthcare acquired infections in operating room, surgical site infections. And so in those critical applications, Standard 170 added this requirement to include the terminal HEPA filter. So we have that there. The other place where Standard 170 requires this is in operating rooms and Class 3 imaging rooms. So the primary supply diffuser array needs to be a Group B non-aspirating diffuser. And so for MetalAire, we have a couple of different options. And there's a standard option, a multi-chamber option, and then our top of the line, what would be filtered option. So the standard option would be our HLC LFD. So this comes in aluminum or stainless steel options. It meets the minimum requirements for Standard 170. So it's a non-aspirating design. There's minimum amount of entrainment. What you see, you've got the perforated face on the front of the diffuser, and you can kind of see through that there's another layer of perforated material back there, and that helps unify the airflow across the back of the diffuser face, so it's uniform when it comes into the room. The HLC CLF that you see here, so this is a kind of step up from the HLC LFD. So instead of having that just basic 2-chamber design, you can see in here, there's a little bit of a definition behind that perforated space. Let me back up. And what that does is that's a chambered baffle that's got a solid panel above it that's got some cutouts that divert airflow into a multi-layer basket of perf that's got some baffling in there. That gives you super uniform flow across the face of the diffuser. That minimizes that surface area coming down into the room, and so minimizes the entrainment. The HLC CLF used to be kind of the primary choice for operating rooms, especially in high-risk applications. It gives you the best performance that you can without having the HEPA filtration. In most of these surgeries, facilities where they're doing the higher risk surgery, they're doing HEPA filtration at the air handler already, which was beyond the minimum requirement. However, starting in 2021, Standard 170, we introduced an addenda that for those higher risk surgery spaces and Class 3 imaging for those higher risk types, orthopedic, transplant, brain surgery, organ transplant, burn victims, and stuff like that, all of those surgeries now have to take place in a room with point of service HEPA filters. That used to be a best practice to have HEPA filtration in those at the diffuser itself. Now it's been moved to a minimum requirement by Standard 170. And so what we have as an option for the filtered diffuser is our HLC GSL. So the GSL stands for gel seal laminar. You have your solid welded construction of the plenum itself. You can see in this area we've got our features for retaining the filter in place. That's a toolless filter retainer. So they push the filter up, use those clips to slide in place. That's going to lock the filter down. And then we have options for including the aerosol test port. So this is really important for compounding pharmacies. It's not as important in operating rooms. Typically, we're not seeing as many facilities doing filter leak testing in operating rooms where it's required in compounding pharmacies. But this provides a means of adding in a port for injecting the aerosol upstream of the filter, and then a port for measuring that upstream concentration while you're doing your filter leakage test. So the other thing that we offer with this is a HEPA alert kit. That is a either 24-volt powered or 9-volt powered battery for an LED indicator that would illuminate the red LED inside the diffuser face, signaling to have the filter change out. That trips at 1 inch of pressure drop, which is pretty typical for most recommendations from filter manufacturers for when that change out's required. And it's just something that we always like to see on one diffuser in an operating room or compounding pharmacy room where they're doing that. You don't need them on all of them because they're not always going to load equally. And so just having one in the space usually is sufficient for that indication, and then all of them would get changed out at that point. Moving on to operating room systems. So as I mentioned, for operating room class 3 imaging, there's a requirement within the primary supply diffusers to be group B non-aspirating. Once we move past that, you have additional supply for diffusers within a room that are group B. And so group B definition is pretty basic: ceiling or high silo mounted with a vertical air pattern. That's not a really great definition within standard 170 because that could open this up to a lot of other options. What we're really discussing in this is a surgical air curtain, like you see here. This is our Paraflow system. We don't really see this much anymore. The primary location we see these in the US are VA facilities where the air curtain system is still the base for their ORs, but we'll pretty much make an exception for anything that follows standard 170. And so most of the VA facilities we've done recently, those are using your standard diffuser layout with coverage over the table plus the 12 inches. In the air curtain, the energy costs and the coordination with it provides a little bit of a challenge, but we still do offer those. We do about 25 to 50 operating rooms a year with the surgical air curtains. Like I said, most of them are VA facilities or sold into Central and Latin America. So talking a little bit about operating room layout. So you've got the diffusers in the room. This layout that you see here meets the requirements for air changes, diffuser coverage at a flow rate that's in the range for standard 170. But the real problem here, and this is something that not standard 170, but FGI guidelines, who standard 170 is incorporated into, they allow within the operating room what they central diffuser array. It moves away from these individual diffusers mounted in the ceiling. And the real concern here goes back to the non-aspirating component of the requirements for standard 170. So when you have the individual diffuser, that's non-aspirating. You saw through the animation, the airflow coming down real slow into the room, but you do have that minimum amount of entrainment. Well, that entrainment starts right at the ceiling level, and as it moves down to the room, if you've got individual diffusers in the space, and you've got these gaps between the diffusers right through here, where the airflow comes down into the room, now you're pulling room air that's at the ceiling level into that flow. So instead of having a entire array that is non-aspirating. The individual diffusers themselves are, but the array as a whole is aspirating, and we want to try and prevent that as much as possible. And so to help with that and help with sealing coordination, like I said, the FGI guidelines added in what's called a central diffuser array. And pretty much what that is a gasketed grid system that allows you to have individual diffusers, but mounted much more closely together. So if you look at that with a integrated sealing system there on the left, you've got all the diffusers pulled together, grouped nice and tightly together. Now, instead of 6 to 8 inches between the individual diffusers where the airflow is coming into the room, now that's down to about 1.5 inches, which is the width of the grid. And so all of that room air that would be pulled along, that's been prevented by pulling those diffusers much closer together. And as you can also see, now we've got those grouped where this perimeter for the diffuser array is significantly smaller than what you would have for the perimeter all the way around on the traditional installation. And so the entrainment that's associated with it is also going to be reduced significantly as well. So to accommodate this, we have what's called our HLC 8CG. So that's our heavy duty sealing grid. We offer this in both aluminum and stainless steel construction, welded modular sections, so up to 4 foot by 6 foot sections that we can have that will ship individually, which get bolted together in sight, raised up into the ceiling, into that single opening that's cut out. And then the individual diffusers, lights, and blank off panels can drop into those. We can also do unistrut integration with that for imaging rooms, cath labs, EP labs. But that is a real challenge. And as we move into that, you can see here, we've got a couple of diffusers in this case, kind of nestled into some panels in the jet board between the rails. And you can do this with the individual sealing grid system, like I showed in individual diffusers, and get coverage and compliance over the table with standard 170. It's just really difficult to do. Takes a immense amount of coordination between all the trades. And like I said, it can be done, but end of the day, a lot of people are really frustrated with the entire process. And so one of the things that we found that helps simplify that, especially with the really tight ceiling space, is going to a modular plenum system. So this is our HLC MPA, so a modular plenum array that you saw with the smoke animation earlier. Common plenum, we integrate the unistrut to support the ceiling level equipment. With that, all of this is then hung from structure, the booms and equipment, all of that would still be mounted to other structural steel. But we do integrate LED lighting, so ties everything together really nicely. One of the things with the LED lighting that we do specifically to help with coordination is, by default, our standard configuration is a tunable color configuration on the lighting. So anywhere from 2700K up to 6500K color temperature. 0 to 10 volt dimming on all of those, that's dim to 0.1%. So dim to dark effectively and throughout the entire color temperature range. The color rendering index for that LED lighting is at least 90. Once you get above 4000 Kelvin, it's 95 plus. And so that's really critical for that color rendering in the space. And especially with it being a surgical site, the way that LED lighting affects the way we see lower levels of that, colors aren't as crisp and clear as they should be under natural lighting. And so that's one of the things that we try to make sure that we have with all of those is 95 plus. So one of the other unique things that we do is we can vary that lighting not only in the color temperature from different colors of white, but we can go from that white to the green lighting. The green lighting is really important for those imaging spaces. Green lighting doesn't wash out the LCD and LED monitors that you have in those spaces. And so you can keep the lighting at full brightness in the room without creating the imaging quality that they're seeing on those screens. And then you also have improved red object visibility. So blood, red things show up almost black under green lighting and have a really high contrast to anything of other color under the green lighting. So stuff stands out really, really boldly when they're in there trying to close people up. And then the last type of system we do, which ties everything together, is the HLC SPA. So that's our structural plenum array. Again, common plenum similar to the MPA, the modular plenum, but now it's got that integrated structural support. So you can see here, it's got a tube frame construction within the unit that's designed to integrate and support equipment rails, and then boom mounts like you can see here in this cutaway. LED lighting is integrated. Lots of other structural support to go with that as well. And then all of this we provide with a day of on-site installation support. And then we have the stamped structural drawings for all the booms and equipment and load calculations for the entire system provided to y'all structural engineer. Next, we'll move on to radial pattern diffusers. So these are probably the coolest type of diffuser that I think that we have. They work completely different than your traditional diffuser that you would have. Your traditional ceiling diffuser or slot diffuser. So this chart here on the right shows the different zones of expansion for a specific diffuser type. Zone 1 is basically as you get away from the diffuser, you have no change in velocity. Zone 2, you have a relatively steep drop in velocity. Zone 3, a increasing rate of decrease in velocity. And Zone 4 is pretty much that maximum rate of decay for velocity that we see through the different diffuser types. For a radial flow diffuser, Zone 1, 2, and 3 are relatively short, and so we start dropping velocity in Zone 4 very, very quickly. If this was plotted for, say, like a plaque diffuser or linear slot diffuser, this Zone 1 is going to be pretty close to about the same distance, but Zone 2 and 3, those would extend all the way out here, Zone 3 even further, and 4. So this scale would extend exponentially because with those you're wanting to get that airflow into the room, mix the space. Well, with these diffusers, we're trying to get as much volume into the space with as little disruption as possible. So if we look at that, here's we have one of our HLC FFRs. This is our flat face radial diffuser. And so what you'll see here is a two-way throw pattern, nice horizontal spread. It's coming down into the room, a really nice hemispherical pattern to that. What you see to about this point right here is about 4 feet down, and that's hitting the 50 feet per minute mark about right there. So that's 6 feet above the ceiling. And this is a 2x4 diffuser operating at 1,000 CFM. So a large volume of airflow being supplied. Again, very short throw to that 50 feet per minute mark, especially in the vertical orientation. If we look at another installation, you can see here, now we got ceiling tiles removed adjacent to the diffuser and showing the ceiling independence of this product. So this is something that we've seen more and more requests and questions about on our radial pattern diffusers is if our throw is ceiling independent. It wasn't. We went and developed this product specifically to get that horizontal ceiling independence with the throw pattern because we saw the need for this in lab applications where more and more people are going to radial throw diffusers. with exposed ceiling applications in those labs, those just kind of more industrial look, and without the ceiling in with other products that will just kind of dump down into the space, and you'll have those higher velocities that aren't really intended. The other really useful application for the radial flow diffusers is in airborne infection isolation rooms. For the air distribution, you need a group A or group E diffuser. So that's either ceiling or high-loss style wall mounted with the vertical throw, that's group E. With a horizontal throw is going to be group A. And so what we want to see or try to do in this application is kind of create a one-pass system of airflow coming into the room, being pushed towards the exhaust grills on the side of the headboard as close to the headboard as you can. And so that's where the throw pattern on the one-way diffuser is really awesome, because you get that nice 45-degree that's going to push all this air motion towards the bed. You'll have that constant motion that's pushing towards the exhaust to trying to capture anything that's coming off the patient in those applications. Right. So moving on to fan filter diffuser products. So fan filter diffusers are relatively simple and are more or less exactly what they seem. I mean, it's a fan and a filter incorporated into the diffuser. So one of the things that we do for our product is, by default, all of these are EC motors. So they can switch from constant airflow to constant speed. That provides some benefits in the field. So if you look at this application here, where we've got the air handler supplying into, in this case, would be a plenum area, serving the fan filter diffusers, pulling that into the space and discharging that into the room itself. So in this application, you've got supply airflow that's going to be less than the primary airflow out of the HEPA filters. So that's going to drive that return air path and let the HEPA filters let the EC motors in the fan filter units set that airflow and maintain that airflow. A lot of times when we see these applied, a single duct unit or a fan powered box unit will be incorporated in these. Typically, this is in compounding pharmacy applications. And instead of having this open return path, now it's a closed loop where you've got a single duct box in line with the fan filter unit that's also trying to control airflow. So you've got two control devices in series. And with those applications and those compounding pharmacies, those will tend to hunt, and oftentimes aren't able to find a stable operating point, and the fan filter units will shut down at that point. What we typically recommend in those applications is there's a couple different ways to go about that. The primary way to go about that would be to, instead of your supply air, instead of maintaining a constant airflow through that single duct box, you can maintain a constant pressure downstream. You're still going to get the airflow measurement readout from your flow sensor that's in the single duct box itself. So you'll be able to track and measure airflow to the space and meet the reporting requirements there. But now what you're allowing is then the fan filters to control their airflow while the supply valve is controlling the pressure. So as the filters load, the ECM motors, those will start to ramp up to compensate for the filter loading. And as those get to their max loading, then the supply single duct valve can open up to accommodate that additional airflow until the point where the filters need to be changed out. The other option is to keep the single duct box as a constant airflow box and maintain that airflow coming into the space, and then operating the EC motors in our fan filter units as constant speed. The downside to the constant speed operation is you don't have the ability for the fan to continue to ramp up throughout its throughout its life as the filter loads. And so it's going to be a set operating point. It can go and be turned up throughout with this thing balancing to adjust and compensate for that. But typically at that set point, the fan filter will maintain and hold that constant speed at the fan, and then the supply air duct or supply air valve will open to maintain airflow until it can't meet design airflow anymore. And at that point, you need to rebalance or change out the filters. So as I mentioned, the HLC FPS is always EC motor. The filter is always room side replaceable. And so removable face, those tool-free quarter turn access for the filters. And then there's two different options of construction for motor access and control enclosure access. So you have what we call the MEA option, which is our motor and electronic accessible option. So those would be accessed to where they can be removed from the room side. So in this case, you would drop the filter. You can see room side access to the bolt heads that secure the motor and blower in place. And then this control enclosure, you have access through a panel on the side here. For the standard construction, everything's accessed from above the room side, so from above the ceiling. So the HLC FPR is the reverse flow unit for this. So the HLC FPS, S is for supply. In this case, FPR, R is for reverse or exhaust flow. So this will have the same options, like I said, on the HLC FPS. So standard construction with motor and controls access available from above the ceiling, and our motor and electronic accessible option from the room side. One of the cool things that we do on the HLC FPR or the HLC FPS, you can see in this case, we've got the LED lighting integrated into these. That's really a option that we see being applied in compounding pharmacies, especially in the USP 800 spaces, trying to minimize the volume of airflow required to meet the air changes. So if you're able to incorporate the lighting into the fan filter diffuser, you're able to take a chunk, either 2 foot of volume throughout the room or 4 foot, depending on how the orientation was, and shrink that space size because you don't have to have both the light and the fan filter in 2 separate spaces. You can combine that, reduces the volume of airflow to meet the air changes, which means you're lowering the fan operating speed and then lowering the noise generated by the fan filter units. Fan filter units by nature aren't quiet. You can see we're calling quiet operation in this case 46 to 51 NC, and that's at 50 feet per minute. So that's about 600 CFM on a 48 by 24 unit. And so that's not entirely real quiet, but it is quiet compared to the others on the market. Okay. That kind of brings me to a conclusion on products and overview. We got any other questions that came in throughout?
I don't see any other questions here. So we'll give it a few minutes. Is there anything else you'd like our customers to kind of fully know about the offering? Right, the MetalAire by Greenheck branding is a little new in our market. You know, some people who lived or worked on the East Coast might be more familiar with the MetalAire brand. So just touching back on that real quick, Greenheck acquired the MetalAire brand several years ago, and at the time investing in not only the production but also the engineering and innovation behind it, and bringing in quality people who are technical experts like Matthew So in our market, we're going to be kind of calling it by MetalAire by Greenheck. Feel free to put MetalAire in your spec or Greenheck in your spec or MetalAire by Greenheck. But that's the way to ensure that, we can provide products on your job. So, yeah, Matt, anything else we should know, or you'd like our customers to know about this product offering and everything you can do?
Yeah, so kind of going back to probably the OR systems is probably the best one to start out. So we can have the expertise to help you basically from the very beginning or at any stage during your project. So right now I'm working on a project up in the Northeast with one of our reps up there, Herman. They've got an old Burlington coat factory, so an old retail facility that they're changing into a day surgery facility. And they basically came to us with, here's the space size, here's what we've got to work with. We need to apply with 170. What can you do for us? And so walk through them, diffuser layouts, coverage options for the lighting systems that they were going with. In this case, they went with separate lights. So they've got a HLC MPA, so our modular plenum array. And actually, it's very similar to the one that you see here, except for it's not quite as long as this one, where it's got a single boom mount in the middle. That's a boom mount, a boom pass through. In this case, it's the MPA, so it's non-structural. We've got a ring of diffusers around that mount, and then they've got a ring of separate lighting that we're including some of our HLC HCG ceiling grid systems around that plenum array for them to drop their lighting in. So kind of a combination of old style design and new style design. And a lot of that was really driven on what they had from structure above, because it was, like I said, an old old retail facility, 20-foot ceilings. And so that they built structural walls, built drill across the top, and then they're hanging the plenums from all of that. So help them all through that. And then same thing on compounding pharmacies. If you've got questions on airflow, changes, layout, diffuser placement, we're here to help.
And like I mentioned, I've worked with Matthew for a number of years, and from the beginning of a project to providing product, right? I've worked with him when it's just starting with architecturals, and maybe as an engineer has done kind of an initial layout, we get Matthew involved, and it usually takes a few meetings to get everybody on the same page of what the intent of the design is and what options they want to go with. The biggest advice I can give is the sooner you can get us involved in those projects, the better. I've seen engineers spend a couple of weeks on a design that actually wasn't compliant to the actual OR, and then Matthew, with his background, was able to come in and politely point them in the right direction for a compliant design over the current ASHRAE standards and FGI guidelines. So get us involved early on those applications. Matthew is a wealth of knowledge, clearly, and I enjoy working with him. But he is the expert, and I've seen that MetalAire Greenheck have the products